Okay, so quadratic formula. The quadratic formula, honestly, out of all of our Algebra 2 stuff, like this is the one formula you're really going to walk away using a lot. It's just another way to factor quadratics, but honestly, it's a lot easier as long as we don't get an I, like that negative, under our square root symbol. So I wrote this yesterday. Here it is. X equals negative b plus or minus. The plus or minus is just telling us that, we have two answers, which we know that because we're looking for the solutions, and parabolas touch our x-intercepts twice, sometimes once, but we're looking for those two solutions there. And then 2 over 2a. So really a lot of times if you talk to somebody, like I was talking to Miss Barber, and she's going to have to teach Algebra 2, and she was like, all I remember from Algebra 2 is negative b plus or minus square root b squared minus 4ac all over 2a. And I just kind of laughed because I was like, yeah, that's like the one formula everybody walks away knowing. It really makes it a lot easier to factor, and we will get to where we just put it all into the calculator. We just have to know when to use it. Okay. So example 1, this is actually our first problem from our handout. I just want to keep it in your notes here for you. Okay, there we go. So again, this is an alternative to using your table, the AC plus B. All right, so here we go. We just know that our A is the invisible 1, B is 2, C is negative 8. Now, when I substitute for any formula, I always use parentheses. That's also how I put it in the calculator. I use all those parentheses too, just to make sure we don't have double negatives somewhere. I want it to look exactly like it's supposed to. Okay, and then I just substitute in b plus or minus b, whoops, almost put b, times 4a, which is 1, c, which is negative 8, all over 2 times 1. Okay, so since this is the first time we're doing this, we are going to test what we call the discriminant. It's a real fancy word for all this stuff underneath here, because I want to test to make sure I don't get a negative. Because as we saw earlier, is if we get a negative under there, we're going to have an imaginary number. We're going to have I. So this is called the discriminant, and we're just going to plug all that into the calculator just to test it. Okay. Eventually, we'll be plugging the whole thing into the calculator. That's what I usually do. And then if it says error, then I'm like, oh, okay, I have to go back. But, or if I get a decimal, I go back and work it out. But that might be kind of a longer route. So here we go. Just cleaning that up. Negative 2 plus or minus square root something over 2 times 1 is 2. Okay. I'm just going to plug that in. Only the discriminant. You'll notice I'm not putting the square root symbol right now. I guess you could. If it said error, you could go back. And I get 36. Well, we know that 36 is a square number, so it's going to give us an easy problem here. So now we're going to work it out. Negative 2 plus square root of 36 is 6, divided by 2. And then we're going to work it out for our second solution, negative 2 minus 6 over 2. Negative, what is that, 4 divided by 2 is 2. Negative 8 divided by 2 is negative 4. That's your answer. 2 and negative 4. I like that better than the table as well. So one thing about quadratic formula is it's not going to work if it doesn't equal 0. If we don't have an equal 0, if you don't even have an equal sign, then we will use our table, the a times c plus b to factor it. But I can make this equal 0 just by moving that 6x over. I cannot combine any terms here, just keeping it in standard form. Now I can use my formula, and the more we write it, the more we know it. So negative b plus or minus square root b squared minus 4 times a times c all over 2a. So we do want to identify our a, b, and c. A is 9, b is negative 6, and c is negative 11. Okay. Now, because this is the beginning of us using this, we are going to kind of break it down a little bit more as we work it out. Eventually, you will be able to like plug all of this into your calculator, once for adding, once for subtracting. If we get a decimal, then we'll go back and show a little work. If not, we'll have our solutions. So, but we're not there yet. Okay. All right. So substituting this in, I get negative 6, negative 6. A is 9, C is negative 11, A on the bottom is 9. Okay, now I'm going to test my discriminant. Just make sure I don't get a negative number under there, because then I really can't use my calculator. Go ahead and clean this up. Negative times a negative is a positive 6. Square root something. All over 2 times 9 is 18. Okay, plugging my discriminant in here. Fancy word for everything underneath that square root symbol. Negative 6 squared minus 4 times 9 times negative 11. And I get 432. Now, my brain's already kind of saying, uh-oh, that's not a square number. But let me test it. Square root 432. Oh, it's not a square number. I got a decimal. So I will be simplifying this radical real quick. So off to the side, going to use my factor tree. And I'm just going to grab my handy dandy calculator. I like 2 as a prime number, so 2 and 2/16. Okay, sorry about that. So again, I like 2 as my prime number to check, just because I can tell it's even. So I'm going to just keep factoring this part. Now, I'd like to take the easiest path here when it comes to numbers. Some of you might be like, Miss, I could have factored this a lot faster using something other than 2, but you know. Okay, and then I know 2 doesn't make 27, but 3 does, and then 3 times 3. Love my small prime numbers. Now, if you're, a little bit wittier than I am, maybe you could have factored that a little bit shorter, but we pick our routes. Okay, so what this becomes now is square root 1, 2, 3, 4. So I get 2 times 2 times 2 times 2 times 3 times 3 times 3. And because our index is a 2, I'm looking for groups of 2 to factor. And I say groups of 2. Yes, groups of 2 repeated numbers. I hope that makes sense. So the square root of 2 is 2. Square root of 4 is 2. Square root of 4 is 2. Square root of 3 is, oh my gosh, I'm saying this all wrong. That's 3 times 3 is 9. Square root of 9 is 3. And then I've got this 3 left over. He's got to stay under that square root symbol, or under our radical. 2 times 2 is 4, times 2 is, but oh my goodness, 2 times 2 is 4, times 3 is 12. Slow down, Hendershot, and bring down that 3. Okay, so now what I'm looking at is 6 plus or minus 12 square root 3. I need a different pen. All over 18. Okay, now I can just clean this up. I can reduce this. It is a fraction. And I always ask myself, does the smaller number make the bigger numbers? That's kind of my route. And 6 makes 12 and makes 18. So I can reduce everything by 6. That method does not always work, but I always check, because then I know I'm reducing by the greatest common factor, and I only have to reduce once. Okay, 6 divided by 6 is 1, plus or minus, because I have 2 options. 12 divided by 6 is 2, square root 3. 18 divided by 6 is 3. And there is my simplified version. And if you wanted to split that up, it could be this one, and then minus 2 square root 3 over 3. Either one of those would work.